Polynomial functions. What is a polynomial? Poly means many. Nomial means terms or numbers. For example, we've had examples of monomials. A monomial would be something like 3x or x squared. Those are one terms. Mono means one, so it's one term only. A binomial has two terms, like x plus 3 or x squared minus 5x. Two terms. A trinomial has three terms, like a quadratic equation, and so on and so forth. That's three terms. This is one term, two terms, three terms. So polynomial is anything to actually define any polynomial is defined a polynomial. You can say this is a polynomial of degree 1. This is a polynomial of degree 3. Remember, the degree is the largest exponent. So whenever you have a polynomial, the first thing you want to do is arrange it so it's decreasing in power in exponents. So that's what a general polynomial looks like. The coefficients are the a's, the numbers in front of the x's. The degree is the n. Once you have a polynomial set up in decreasing order, always look at the exponents and set them up that way. The first term in your polynomial, the first term of your polynomial is called the leading term. It's the most important one. The leading term has a sub n, the leading coefficient, and n, the degree. And together, both of these give us an idea of what the graph's going to look like. What is called end behavior. End behavior defines the directions both ends of the graph will take going to infinity. Ends of the graph. The directions of both ends of the graph as x goes to positive and negative infinity. For example, here's a chart that tells us just by looking at the function that's given to you, by looking at the leading term, this is what you know what the graph's going to look like. So the top one is the degree. If n is even or n is odd. If a sub n is positive, or is the leading coefficient positive or negative? In other words, is the leading coefficient, is it positive or negative? Remember, these are just the end behavior of the last intercept. So if a is positive, is the coefficient's positive and n is even, both ends point the same direction, they point up. We don't know what happens in the middle with all the other intercepts and the vertices, but we know at the very end, the last intercepts, they'll both go up. If the coefficient is negative and n is even, then they'll both point down. So if n is even, they go the same direction. If n is even, they go the same direction. If it's positive, it goes up. If it's negative, it goes down. And here are all my x-intercepts. If n is odd, if your degree is odd, but a is positive, it's an increasing function, meaning it goes up to the right, down to the left. Now, if a is negative and n is odd, that means it goes down. It's a decreasing function. It goes up to the left, down to the right. Just by using this right here, you can tell what the basic shape of the graph is going to have. Polynomial functions. Here are some examples of them. F of x is equal to x squared plus 3x plus 1. It'll look like this. Actually, it's supposed to go up to 1 here. Remember, also, I have to back over here. So the coefficients that the degree is n, the constant number, a sub 0 is the constant number. That is your y-intercept. So the last number, if there's a number without an x, it's the constant, that's your y-intercept. If it's positive, it's positive. If it's negative, it's negative. That's why this one here, notice the y-intercept of this one is positive 1. So we had to cross that positive 1. Here we have a constant function. It's a horizontal line going through -3. So what do we know about this one? We know the y-intercept is at -1 because of that. We know that it's positive, so it has to be increasing function. It's a odd, so both ends point in different directions, and it's positive, so it's got to look something like this. We just don't know what the x-intercepts are. The x-intercept is what the big thing about this chapter is all about. What if we had this one? -x⁴ plus 2x³. With this one, we could do a little bit of work since it's not too much in there. What do they all have in common? Yeah, what do both these have in common? How many x's? 3. Yeah, so since this first one's negative, I can take out a -x³. Since I took out the negative, I mean, I have to change. I took out 3 of them. I only have 1 x left in there. What's my y-intercept? Y is 0. And we know that from this. I set both of these equal to 0. These, whenever you have an equation, you factor it. Those tell you the x-intercept. So I get 0 for one of them, and then x equals 2 for the other one. What else do I know? What else do I know about the graph? Since these are my only x-intercepts, these are my endpoints. Where does the graph go? Same direction or opposite directions? Why? The degree is 4. If the degree is even, they go the same direction. If the degree is even, they go the same direction. They go up if it's positive, down if it's negative. So we know it's the same direction, but it's negative, so they're going to go down. So the only thing we know about this graph, it looks something like this. So those are examples of polynomial functions. Non-polynomial functions. Absolute value of x plus 2. So what that tells me is it's a horizontal shift 2 to the left, and its absolute value. The graph looks like this. This is a square root function. It's a horizontal shift 1 to the left and 1 down. So there's your graph. And at 0, the square root of 1 is 1. 1 minus 1 is 0, so it goes to the origin. X to the 4/5 is a graph that looks like this. These are bends. Think about because of support. And the last one has a vertical asymptote at 1, horizontal asymptote at 1. So the graph looks like this. That's -3. And that's -3. So what do we notice about the difference between polynomial and non-polynomial functions? What do they look like? What makes one a polynomial and the other one a non-polynomial? Polynomial functions are all continuous. There are no holes anywhere. There are no sharp corners, no points, no discontinuities, no jumps. That's what a polynomial is. It has to be smooth and continuous. Non-polynomial functions, they have corners, they have points, they have a terminating point. It's not continuous. It can't go on forever, and it's a discontinuity. All right, so that's the difference. If it, whereas a polynomial function cannot have a point, an edge, a endpoint, or a jump. Yeah, we already talked about those. Let's look at example 1. We're going to match each of these functions to their graphs by using the leading term test we just did earlier. And these are the basic shape of the curves. Here's A, here's B, here's C, and here's D. Which ones go with which? So this first one, what do we know about it? We won't only look at the leading term and the constant. Oh, it's x to the 4th. Yeah, x to the 4th is even. So and it goes up or down? Up. So it can't be that, can't be that, can't be that, so it has to be this one. B. So the opposite directions. And it goes where? Up or down on the right? Down. So the only one that goes down to the right is this one. Then this one, it crosses at 1. So it goes up on the right, down to the left. It's positive. So it has to be A. And this one is x to the 6, negative x to the 6. The y-intercept is 0. It's even, so it goes same direction. It goes down, so this one has to be C. Well, you have them in your picture.
Oh, they're on there?
Yeah. In your packet. Finding zeros upon, what does it mean finding zeros of polynomial functions? Yeah, zeros, same thing as solutions. The same thing as x-intercepts. Zeros. Factors. And roots. Those are all the same, they're synonymous. Okay, what if I gave you a quadratic equation? What do you do there? Because we know the basic shape of the curve. It's going, both ends go same direction. Since it's positive, they both go up. The y-intercept is at -8. So how do we find our x-intercepts? Factor and set it equal to 0. X and x. What signs go in there? Yeah, opposite signs. One's plus, one's minus, and the bigger number goes where? In the minus. What times what is 8? When you subtract them, you get 2. Very good. So my x is equal to -2 and x is equal to +4. And because it's a quadratic equation, our vertex is always a midpoint between your two x-intercepts. Or we could use x equals -b over 2a. Negative of -2 over 2 times 1 is 1, 2 over 2, which is 1, at 1. So we know that it's going to be somewhere here. The graph will look like this. So far, so easy? Yeah, so once I give you an equation, factor it out, look for the zeros, plot those points, and what we talked about, the needing the leading term test, the end behavior, you can see what the graph's going to look like. You can start sketching it. Find the zeros. What do we know about this graph? So where are my x-intercepts at? Well, set these equal to 0. X minus 2 equals 0. It's at 2 and at -1. Those are my x-intercepts. Because it happens 3 times. What's my y-intercept? How do you find the y-intercept? Set x equal to 0. If you set x equal to 0, -2 cubed, 1. -2 cubed is -8 times 1 is -40. What's our leading coefficient? And what's our degree? Because for leading coefficient, is it positive or negative? Well, in front of all the x's, they're positive. This number here is positive, so this is going to be greater than 0. Actually, it's going to be just 5. Because it's this times this times this times this times 5. What's my degree? How many x-intercept? I could count how many solutions I have, or I could just count here. Yeah, these are called multiplicities. The multiplicity is how many times the answer repeats itself. So n is the summation of all your multiplicities. So we have 3 plus 1 equals 4. So we know it's positive and it's even. So we know that both ends point the same direction. Our graph's gonna look something like that once we finish graphing it. Find the zeros of this one. So what is a sub n and what is n? Well, is a sub n, is it positive or negative? It's negative. What's n? So if it's negative and 4, what do we know about the graph? They're both going down. So what are my x-intercepts? +1 and negative. Very good. So we know the graph goes down from there. What's my y-intercept? Set x equal to 0. It's got 1, 2, 3, too many solutions. 1, 2, 3, yeah, at most. So -1 squared is 1, 2 squared is 4, the negative in front. So that's the basic shape of it. We'll go further into that in a minute. Well, the multiplicities tell us a lot as well. One method of factoring cubic functions is by called grouping. Put the first two terms together inside parentheses, and then the last two terms. Now, what can we factor out of the first one? X squared. So it leaves me with x minus 2. Since this first term is negative, I take out the negative, and they both have a 9 in common. So I divide by -9 inside there. I get x minus 2. What your objective is to get the same numbers inside parentheses. Because once you have the same numbers inside the parentheses, these other two numbers become their own parenthesis. X squared minus 9 is the same thing as x squared minus 3 squared, which is the difference of two squares. So it's x plus 3, x minus 3. Remember, a squared minus b squared is a plus b, a minus b. So my zeros are at 2, -3, and 3. Those are my x-intercepts. The y-intercept is 18. It's a cubic. N is 3. So our graph's going to look something like this. And we know that the graph's going to look something like this. Because all the multiplicities are odd. If the multiplicities are odd, then the graph crosses the graph at those points. If they're even, they bounce. Look at the graphs of these two. X squared looks like this. It bounces. X cubed goes through it. So whenever the multiplicity is even, it bounces off that x-intercept. And the last one, that fire drill thing, you really wasted our time. And then we have this one. Can we factor it out? It's quadratic. How do we know it's quadratic in form? Only three terms. The middle term times two. Very good. So remember, we have x squared and x squared. We'll always solve for the middle term. We have opposite signs. And the bigger number is positive. So what times what is 45? When you subtract them, you get 4. There you go. So we set both of these equal to 0. Square root, we get x equals plus or minus 3i, and x equals plus or minus square root of 5. Those are all my solutions. Because that's pretty much what we've been talking about all along. How to find the x-intercepts. Next, because the whole purpose is we're going to start building up on harder equations than this. So far, we've been having pretty easy equations on how to factor them. Now we're going to start looking at much more difficult, much more larger equations. That's what the whole purpose of chapter 4 is all about, and how to graph these as well.